Okay, my name is Brian Duggan, and I'm going to be talking about Perl 6 Superglue for the 21st century. Okay, first I'd like to thank my company PromptWorks for sending me here. We're a consultancy in Philadelphia, and we work in a lot of dynamic languages, Perl 5, Perl 6, some Python, Ruby, JavaScript, Elixir, Clojure. Okay, so Superglue for the 21st century. The other day, I went to my bank, or to the website for my bank, and I downloaded a CSV file because I wanted to find out how much money I had spent and import it into my homegrown money tracking software. This is the CSV that I downloaded. Does anybody notice anything strange about the CSV? Besides the fact that in the US we do the dates a little differently. Yes, there's a comma in the description of one of the places, one of the fine dining establishments that I had visited. And so I thought to myself, okay, maybe there's something wrong with this file, because at least from what I knew about CSVs, if you have a comma in one of your fields, you're supposed to either escape it with a backslash or put quotes around it. But then it occurred to me that actually this was a very modern file. And I just didn't realize it, but this was a perfectly valid way to represent the data. And obviously, since this was a bank with a $2 trillion net worth, they couldn't possibly have made a mistake in the format. So I realized that actually in the 21st century, we have CSV files that don't need to have the commas escaped in the fields. The only problem is a lot of our CSV parsing libraries haven't caught up with this new way of representing data in CSVs. But really, if you look at it, it's a pretty simple format. There's only one field that can have a comma in it, the description. And the other ones, you have a type, the first one. You have a comma. You have two dates. They're pretty well defined. You're not going to have any commas in those. Then you have the description, and then you have an amount. And so I realized this is actually totally unambiguous. There's no reason that comma has to be escaped. And once we write this line here, which describes what a line of the CSV looks like, we can basically put it into a grammar and say, well, here's what a line of my file looks like, the line that starts with type. And then I can just describe those different types. So the first one, the type, is a capitalized word, so capital A to Z, followed by a number of lowercase letters. The date is a bunch of digits and slashes. And the amount is a minus sign and a period and a bunch of numbers. The only thing that may be a little funny about this is that you notice some of these say they're regexes, some of them are rules, and some of them are tokens. How many people know the difference between a regex and a rule and a token? They are, so the difference is ratcheting and white space, and that's about it. So a regex is a regex that we know, but if you don't have to backtrack in your regex, then it's called a token. And so it's actually pretty intuitive that this description here, which is the one thing that's a little weird, has to be a regex and not a token. And the top one, which describes a sequence of lines with some white space at the end, that one is a rule, and the white space at the end says that's actually matching any kind of white space, not just a space character. So the point here is that, so we say csv.parse, and that parses our CSV, stores the match in $/, and then we can just write a little line like this that says, on date sub 0, I spent minus amount at description. and there's the postfix $4 line. So if you're new to Perl 6 grammars, some of the syntax may be a little odd, but essentially in Perl 5, we have the $_ topic variable. Perl 6, we also have the $/ variable. And $angle brackets word is the same as looking something up in $/. So this goes through the list of lines, and notice that the fields are just named right after the tokens and the regexes that we just created. And then for each one, we can say $angle bracket date or $angle bracket amount. And essentially, we're doing a hash lookup, but we're using the method call syntax. That's what the extra dot does. And we're doing it on $_. So it's sort of a lot of words to explain it, but when you look at it, it's actually pretty readable. So the point here is that in the 21st century, data is still pretty messy, but regular expressions don't have to be that messy anymore now that we have this nice tool of grammars. And grammars aren't just for doing complicated things, they're also just a nice way of doing things that are just a little bit harder than regular expressions. Okay, so that was grammars. Here's the outline of my talk. For the rest, I'm basically going to be going through a few more examples of how I've found Perl 6 to be useful for some everyday problems. I'm going to talk a little bit about running external programs with QX, shell, run, and proc async. And then how supplies fit into that and how to test some of these things, which can be hard to test when you have external programs. And on the right-hand side, you can see some of the examples I'm going to be using. So interacting with GitHub, interacting with AWS, interacting with my bank. Okay, so a little bit about QX, shell, and run. And this may be review for some of you. But QX, pretty straightforward. It's just like Perl 5. You give it a string, it executes the command, and returns the output. If you want to interpolate, then it's QQX instead of just QX. Shell and run are almost the same, except that shell uses a shell. And both shell and run return a proc object, which we'll hear more about later. So here's a little example of using QX. I'm not going to do any more grammars, by the way. So let's look at another technique for parsing output of QX that uses some of the other built-in Perl 6 features. Okay, so let's say you run AWS S3 LS and you get a list of files. How many people have seen this kind of thing before because they use AWS for stuff? Okay, only a few. So they have this really weird output format where they put a pre for directory because they're really talking about a prefix, I guess. And you know, some of the file names in AWS may have spaces in them. So let's see how we might take this list and just sort of easily turn it into two arrays with directories, one with directories and one with files. Taking into account the spaces and all the extra weirdness that comes back from this command. So what we want to do here is we want to classify these. And there's a really nice built-in command in Perl 6 called classify. So what you can do, classify takes a list, and essentially it turns it into a hash. It says, you tell me how you want me to turn this list into a hash. Give me a bunch of keys, and then I'll put them into the corresponding key of the hash. So the classify line here, you can see takes the ternary operator, and if it matches pre, then it returns dir, otherwise it returns file. So then we have a little extra stuff at the top here where we're running our QX and skipping the first one, trimming some white space. And then we use the given to topicalize it, so put it all into $_. And after we do that, inside of the body here, we can just assign to dirs and files by splitting into up to 2 pieces for the dirs and up to 4 pieces for the files. So it's a little dense, but I wanted to give this example. There are a lot of handy things like this in Perl 6 you can use in addition to grammars for deconstructing text. Another handy way of using shell and run is with the indir command. So indir kind of does changes the working directory just for a little bit, and then changes back when the scope is done. And if you combine that with shell, essentially you have sort of like bash with a -e flag, where you want to exit if something goes wrong along the way. You have to be sort of careful here. So what happens here is if the first shell fails, if it returns a non-zero exit code, then that returns a failure object. A failure is really cool because it's kind of like a delayed exception. It doesn't get thrown unless you have it in a sync context. So in other words, if it's a statement like this, then if your command exits, an exception gets thrown, it doesn't go on to the next command. If it weren't in a sync context, you could assign to it, and then you would get a proc object. And the same thing works with run. So here's another example with run. In this case, I'm not just running /bin/cat, but I'm also saying I want to deal with standard in and standard out for this command that I'm running. So that's why I send :in and :out at the end there. So after that, you can send things to your command. I can say proc.in.say meow, and then say proc.out.get slurp, and it'll print meow. But if you're reading this, you may hesitate a little and say, well, wait a second, what happened to my command? Is it still running? When did it start? So there's actually, it's a little bit asynchronous here because your command actually is running while you're sending stuff to it. And there are certain conditions that'll stop your command from running, like if you check the exit code. But really, if you want to interact with commands asynchronously, there's a better way to do it. And that's with proc async. And don't worry, this is leading back to some real-world examples in a minute after we get past the bin/cat examples. So to use proc async, you make a new object. And if you're going to write to it, if you're going to use standard in, then you send :w. And if you want standard out, then you send :out. After you make the object, the next thing that you do is you set up your taps. So taps are code that you want to run whenever something comes from standard out. So here's setting up a tap on standard out saying whenever I get a word, print this out. Say the cat says $word. So we haven't actually started the command yet, we just set up the taps. Then you can call proc.start, which schedules the proc to be run and returns a promise, after which you can send stuff to standard in just by calling proc.say. And if you close standard in, then that'll finish cat, so cat won't be doing anything anymore. And then you await the promise, and then it'll finish. So you get the cat says meow. So here are all the steps. Make an object, set up the taps, make a promise, which starts the process, do your interaction, close standard in depending on the command that you're running, and then finally wait for the promise. So it's a very nice way to sort of cleanly interact with other processes. And what I want to do now is drill in a little bit on the setting up of the taps. So when we set up a tap like this, what we're actually doing is using something called a supply. And as is usually the case with Perl 6, there's more than one way to set up a supply. So the other way to set up a supply, instead of calling tap, is to use the whenever construct. So whenever is really interesting because when you look at it, it almost kind of looks like a loop, except it's not a loop. You're setting up a tap. So what this does is we're saying start react whenever proc.standardout. And so the start says, okay, put this on another thread. And then the react says, okay, just do this until the supply is done. And then whenever is essentially the same as the code above that's saying take this tap and associate it with this supply. And the reason this construction is so cool is because you can then chain supplies together. So let's say we make a supply. So there's also a keyword supply, which allows you to make a supply. And the supply emits words whenever they come from standard out. You can then take that supply and wrap it in another supply that uppercases it. And putting them together, you get the uppercase version, the cat says meow. Okay, so a practical application. Have you ever had to deal with log files that look something like this? Yes, so what's the problem? Well, you hate looking at them, they're annoying, and you would like to filter them, but unfortunately, you can't just filter by new lines because some of the log messages probably have new lines. So what you really want to do is batch your logs messages together, batch your lines together, break them up into messages, and then make some rules that filter on the messages. So you can do that with the same techniques. Essentially, you hold on to a little buffer here, $last, and then you just emit it if you get something that's saying like, here's a new log message. And so this gives you a supply of messages instead of a supply of lines. Then you can take that supply and you can set up a bunch of conditions, like when this, when something else, and when is kind of like if, except it jumps out of the block after it succeeds. And then after that, you start your process. There's one more very important step that you should always do, of course, which is to make an ASCII art spinner. So every 1/10 of a second, you want to do the next one in this series so that when you're watching your log, instead of seeing something like this, you see something like this, where you start it, you get your nice spinner, you're more relaxed, and then finally, when something happens, then you get some informative messages. Okay, so one final thing, which is testing. So whenever you have external processes, it can be hard to test because you don't want to run the processes while you're testing. You want to mock them. And there's a very easy way to do this with Perl 6. You can just use wrap. So if you want to wrap, if you say &shell.wrap, it says instead of running the shell, just run this command that I just gave you right here. So you give it a subroutine. Maybe your subroutine takes the arguments that were sent and puts them onto a list. And then after your shell commands run, you sort of check your lists, and this is safe. You can run this. It won't do rm-rf star. And then you can check and your test will pass. And you can also do this with QX. Except that instead of lowercase qx, you use capital QX. And if you wrap that, that'll wrap both QX and QQX. So that's it. In conclusion, there's a lot of weird stuff in the world in the 21st century, and some of these primitives with Perl 6 can help interact with different services and external commands. And that's the end. Thank you very much.